demonstration, we'll show you how to leverage Ansible for cloud provisioning by writing a simple playbook. Then we'll use Tower to scale up that playbook to allow for rapid provisioning of lots of systems and to provide a self-service push-button interface so that even non-Ansible experts can rapidly deploy lots and lots of hosts. Today we'll use Amazon Web Services as our cloud deployment target, but Ansible and Tower support a wide variety of public and private cloud platforms, including AWS, VMware, Google Compute Engine, Microsoft Azure, Rackspace, OpenStack, and many more. Let's craft a simple playbook to provision any number of hosts in AWS. For this, we'll use the EC2 module. The EC2 module is one of many AWS modules that provide an Ansible interface to the most popular AWS services. We'll use EC2 to provision new instances. It works by talking directly to AWS through the Boto Python libraries. Let's write our playbook. First, we'll start with the hosts declaration. In this playbook, we're only concerned with provisioning new instances, and to use the EC2 module to do that, we'll run the module locally on our Ansible control machine or Tower server. So we'll use localhost for the hosts declaration here. Of course, the connection will also be of type local since we're running this module locally. We don't need to gather facts for this playbook since we're just provisioning new hosts. So we'll turn that off. Next, we'll define some default values for variables that we'll use later. These are parameters that we may want to override later either on the command line or in Tower. Now for our tasks. First, we'll call the EC2 module with our parameters. The image we're using here is a generic CentOS 6, but we should be able to launch any image with this playbook, including Windows-based images. The EC2 module supports a count parameter, which we'll use to launch any number of instances. At the end, we set wait to true to wait for these instances to come up before you move to the next task. We also capture the result of running the module in the variable called EC2. This will be a list of instance objects that we can query for instance metadata, like the host name of a newly created instance. We'll use that variable next in the wait for task. This task will wait for the specific port to become available on the new running instances. Since these are Linux hosts, we'll wait for port 22 to become available so that we don't complete the playbook until SSH is available on every host we just launched. That helps us to know that we can then run subsequent Ansible tasks directly on those hosts, such as if we wanted to start installing software and configuration immediately after provisioning. That's out of scope for this demonstration, but it would be trivial to do. Just start executing a new Ansible play directly on the newly created hosts right from this same playbook if you like. For this demo, that's the end of our playbook. We just want to provision a count number of instances and wait for SSH to become available. Now let's run this playbook to test it out. First, I'll need to export my AWS credentials into the environment so that Ansible can pick them up. When we use Tower, Tower will provide the credentials for us. But here on the command line, we'll need to set them in the environment or in our command line arguments or in the playbook itself. To keep those credentials secret, I don't recommend them putting them in any of the playbook artifacts that you will check into version control. So I'm going to set this into the environment and then we'll run our playbook. We'll just run the playbook with the default parameters, so we'll just be launching a single AWS instance with this run. Great! Our playbook is working. We can see our hosts here in the AWS console. And there's our newly provisioned instance. Now let's check this playbook into version control and import it into Tower. With Tower, we'll be able to scale out the use of this playbook by deploying it with the push of a button, and even exposing it to users who are not Ansible experts. In this way, we can provide a self-service environment to our users, or even delegate responsibility to other staff who may or may not be familiar with how to run Ansible on the command line. Of course, Tower will also keep track of who has run this playbook and allow me as the administrator of Tower to audit its use. Since we've checked this into version control, we can see this up in our GitHub repository. This sandbox repository is public, by the way, so feel free to grab this playbook and follow along. Now let's import this new playbook into Tower. I checked that playbook into an existing project of mine, which I've previously set up in Tower. Here's the settings for the sandbox project. I selected source code management type of Git and simply populated the URL from GitHub. Since this repository is public, there's no credentials or further configuration required. Let's synchronize this project with the GitHub repo to pull in that latest new playbook. Now our new playbook should be imported into Tower. Let's create a job template with which we can set the parameters to run this job. A job template simply captures the options you would normally specify on the command line to run a playbook. It's a great way to drive consistency in your deployments, as the playbook will be run exactly the same way every time you launch it through Tower, and it provides a nice self-service interface to your users, whether they are Ansible experts or not. Let's create a new job template for this AWS provisioning playbook. We can override the default values of any variable we are using in the playbook by specifying new values here in the template. This is the equivalent to using the -e argument with Ansible-playbook on the command line. Now, we may want users to be able to specify some of these values at launch time. If we trust the user, we can give them permission to edit this template. But for most users, we're going to want to put some guardrails around their input and treat it more safely. To do that, we can use the survey feature of Tower. The survey is a form builder that allows us to ask the user for input via a launch dialog. We have lots of options for what types of input we'll accept. Here we'll ask for the number of instances to launch and the tag we should use to name these instances, but really anything is possible here. Now we are ready to launch our hosts. But before we do that, let's take a quick peek at our inventory and see what's already running up in AWS. Here we see our existing AWS inventory that I previously set up. With Tower, you can have as many inventories as you desire. Inside each inventory, you can create groups of hosts. These groups are actually what sync to an upstream inventory provider like AWS. Here you can see that I have configured this group to sync directly with AWS, which is one of the many built-in deployment platforms that Tower supports. I added my AWS credential here, and you can see that there are a few options for limiting the set of hosts that this sync will return. Now when we sync, we'll see Tower overwrite this old inventory state with what's actually currently running up at AWS. Here I can limit the inventory group to just our demo video hosts, like so. Now, when we synchronize this group, we'll see Tower overwrite this old inventory state with what's actually currently running up at AWS, but limited to just our demo video hosts. Excellent. And there we have our one demo video host that we launched previously using that playbook on the command line when we were testing. So there it is. Now we're going to launch a few more. Now I mentioned that I had attached my AWS credential to this inventory group. This is an important value of Tower above and beyond Ansible on the command line. Credentials are imported into Tower and are not retrievable in plain text by any user. Here you can see that I have previously imported my Amazon access key and secret key, the same ones we used on the command line, but they aren't visible to me or to any user, even the admin. These secrets are encrypted and stored in Tower's database and will never be retrievable by any user. So we can allow our users to use these credentials to launch playbooks, as we're about to do, but the user does not need to actually have the credentials or even know what they are. So now let's launch our playbook and see this all work. We'll specify our tag of demo video, and we'll also bump the count up. Let's get crazy and bump it up to 100. Tower will show us all of the output of running this job. We can also view the standard output as if we were running this on the command line, as we did at the beginning of this demo. And success! Tower took about 4 minutes to complete this task of launching 100 of these instances for us. This result will be logged in Tower forever, or until an admin cleans out old jobs. This provides an audit trail that we can refer to at any time to see how this job was completed. Going back to the inventory, we can verify that our hosts are up by resyncing this inventory again. And here we see our hosts, 101 of them actually. Now these hosts are up and ready for us to further configure them with Tower and Ansible. Thank you for viewing this demonstration. More information and a free trial of Tower